Welcome to Astronomy Daily, your friendly and engaging source for all things space and astronomy. I'm your host, Anna, here to guide you through the latest cosmic headlines. Whether you're a casual stargazer or an astrophysics enthusiast, we've got news that will spark your curiosity and keep you informed about the universe. Today, we'll explore groundbreaking research linking planetary influences to the sun's magnetic cycles, an innovative mission proposal to explore Neptune's largest moon, Triton, the ongoing debate and new proposals about how we define a planet, and the exciting collaboration between Airbus and Astroscale UK to tackle space debris and in-orbit servicing. So let's dive into today's stories. New evidence is shedding light on a long-standing cosmic mystery. How do planets influence the sun's magnetic cycles? Researchers at the Helmholtz Zentrum Dresden, Rossendorf, and the University of Latvia have unveiled a groundbreaking physical model that supports what is known as the planetary hypothesis. This model proposes that vortex-shaped currents on the sun, named Rossby waves, act as intermediaries between the gravitational influences of planets like Venus, Earth, and Jupiter, and the sun's magnetic activities. For years, scientists have been puzzled by the sun's cyclical fluctuations, with the Rossby cycle being the most well-known, where every 11 years the sun reaches a radiation peak. Yet what makes these cycles occur so reliably? This is where the new model comes into play. The sun, often referred to as a massive dynamo, generates magnetic fields through complex, swirling movements of electrically conducting plasma inside it. According to Dr. Frank Stefani, one of the lead researchers, the key revelation is the role of planetary gravitational pull. Much like how the moon's gravity affects Earth's tides, the combined gravitational force of Venus, Earth, and Jupiter appears to exert a synchronized influence on the sun every 11.07 years, aligning with the Rossby cycle's rhythm. What makes this discovery truly fascinating is the role played by Rossby waves. These waves, similar to large-scale wave movements in Earth's atmosphere, help transfer the needed energy to synchronize the sun's dynamo with the rhythms dictated by the planets. This not only explains the Rossby cycle, but also clarifies shorter cycles called Rieger cycles, which occur every 118, 193, and 299 days. So how significant is this finding? It's monumental. By revealing how Rossby waves mediate the planet's tidal forces, researchers can now predict and understand even longer-term solar cycles, offering new insights into the sun's behavior and its interactions with the rest of our solar system. The study's robust mathematical foundation also lends strong support to the previously controversial planetary hypothesis, paving the way for future research to further unravel these intricate cosmic connections. Let's talk about how planets set the solar beat. Dr. Frank Stefani and his team at HZDR and the University of Latvia have delved deep into the interaction between the gravitational forces of Venus, Earth, and Jupiter, and the sun's magnetic field. Imagine the sun as a giant dynamo powered by electrically conducting plasma. As it swirls and churns, it generates magnetic energy in an 11-year cycle known as the Rossby cycle. Now, these planetary forces come into play. Think of the gravitational pull from Venus, Earth, and Jupiter as a gentle yet persistent nudge. Every 11.07 years, these three planets align in a configuration similar to a spring tide on Earth, which affects the sun's magnetic activity. Dr. Stefani explains that this alignment consistently pushes the solar dynamo, reinforcing the Rossby cycle with remarkable stability. But there's more. The researchers identified Rossby waves as the intermediaries in this process. Rossby waves are large-scale, vortex-shaped currents on the sun, akin to the wave patterns in Earth's atmosphere that influence weather systems. These waves are crucial because they transfer the energy needed to synchronize the sun's magnetic cycles. During the spring tide alignments involving Venus, Earth, and Jupiter, the tidal forces activate these Rossby waves, which then travel at high speeds, providing the necessary oomph to the solar dynamo. This not only keeps the Rossby cycle running smoothly, but also explains shorter solar cycles like the Rieger cycles, previously unexplained. The beauty of this discovery lies in its simplicity and comprehensiveness. By integrating the gravitational forces of the planets and the dynamics of Rossby waves, Dr. Stefani and his team have developed a model that can predict various solar cycles with a high degree of accuracy. This model underscores the intricate dance between celestial bodies and the powerful forces at play within our own sun, offering new insights into solar activity and the rhythms that govern our star. Steve Olson and Jeffrey Landis have an exciting proposition for a new mission to Neptune's largest moon, Triton. Known as the Triton Hopper, this innovative mission aims to explore Triton's surface in a way that's never been done before. The concept revolves around a lander that uses a cryogenic pump to extract propellant directly from Triton's icy surface. Unlike conventional rovers or landers, the hopper is designed to hop across the moon, covering significant distances over time. The propulsion system of the Triton hopper is truly fascinating. By heating the collected propellant material to a high temperature, the system builds up pressure until it can release a jet stream, powerful enough to overcome Triton's weak gravity. With gravity just half that of our own moon, the hopper can theoretically travel up to 5 kilometers a month. Loaded with scientific instruments like ground-penetrating radar, spectrometers, a microscope, and even a seismometer, this mission could unlock a wealth of data about Triton's geology and potential for biological activity. One of the biggest challenges for any mission to Triton is simply getting there. Olson and Landis have considered various propulsion methods, including solar electric propulsion and aerobraking in Neptune's atmosphere, to safely deliver the hopper to Triton's surface. Once there, the hopper's unique design allows it to traverse the landscape, conducting experiments and gathering data that could answer key questions about this enigmatic moon. Thanks to the NISC's funding and advancements in cryogenic technology, the Triton hopper could redefine how we explore distant celestial bodies. While the mission still faces competition and uncertainties about its future, its innovative propulsion system and ambitious objectives make it a tantalizing glimpse into the future of interplanetary exploration. Stay tuned as we follow the developments of this groundbreaking mission. The definition of what makes a planet is back up for debate. You might recall that in 2006, the International Astronomical Union, or IAU, caused an astronomical stir by reclassifying Pluto as a dwarf planet. This decision left us with 8 official planets and sparked ongoing discussion among astronomers and space enthusiasts alike. So what was behind this controversial move? The 2006 definition laid out 3 key criteria for an object to be considered a planet. It must orbit the sun, have sufficient mass to maintain a nearly round shape, and have cleared its orbit of other debris. While Pluto ticked the first 2 boxes, it failed the third due to its crowded neighborhood in the Kuiper Belt, where it shares its orbital path with other similar-sized objects. Fast forward to now, researchers like Jean-Luc Margot of UCLA are striving to refine this definition. Margot and his colleagues have proposed a new approach that focuses more on dynamical dominance and mass. According to their new proposed criteria, planets will be categorized based on whether they dominate their orbits and their mass, rather than solely on their ability to clear their orbital path. Using sophisticated algorithms, Margot's team has identified clear separations in the dynamical characteristics of celestial bodies, aiming to make the classification process clearer and more precise. They suggest precise mass thresholds, addressing vague terms like nearly round, and also ensuring the definition can apply to exoplanets, which the 2006 criteria notably excluded. One thing is clear, Pluto isn't likely to regain its planet status under these new definitions. But that's not necessarily a bad thing. Margot wants to reassure us that whether or not Pluto is labeled a planet doesn't diminish its significance or the scientific intrigue it holds. The goal of this refined classification is to provide clarity and consistency, aiding both the astronomical community and the public's understanding of what exactly constitutes a planet. The IAU is expected to discuss these proposals further at their next General Assembly in Rome in 2027. Whether they adopt these changes remains to be seen, but the debate certainly highlights the fascinating complexities of our universe and the continual evolution of our understanding. Let's talk about an exciting development in the world of space sustainability. Airbus Defence and Space and Astroscale Limited have come together in a groundbreaking collaboration aimed at advancing in-orbit servicing and space debris removal. This partnership could be a game changer for how we operate and maintain our space assets, pushing us towards a more sustainable and efficient space environment. So what exactly are Airbus and Astroscale up to? Their collaboration is set to tackle several key objectives. First and foremost is space debris removal. With thousands of pieces of junk cluttering our orbit, finding ways to identify, capture, and eliminate this debris is more crucial than ever. This isn't just about keeping space clean, it's about ensuring the safety of ongoing and future missions. Imagine the stakes if a piece of debris collides with an operational satellite. They are incredibly high. One of the most intriguing aspects of this partnership is their focus on in-orbit servicing. We're talking about developing technologies that can maintain, repair, and even upgrade satellites while they are still in space. This could dramatically extend the lifespan of these satellites, reducing the need to launch replacements and consequently minimizing space debris. It's a vision of a space industry that is both efficient and sustainable. They're also honing in on in-orbit rendezvous and proximity operations. This involves advancing our ability to maneuver satellites precisely and safely in space. The development of advanced navigation and docking technologies is crucial for both satellite servicing and debris removal missions. Think of it as creating an intricate ballet in the skies, where every move needs to be perfectly coordinated to avoid collisions and complete complex tasks. Another fascinating area of their collaboration is in-orbit space assembly and manufacturing. They're exploring methods to construct and assemble spacecraft components directly in space, supporting a circular economy where resources are reused and repurposed. Imagine building a new satellite from the parts of an old one. This could significantly reduce space mission costs and further promote sustainability. Last but not least, they're working on satellite refueling and life extension. Ensuring continued operation through in-orbit refueling can extend a satellite's functional life, again reducing the need for frequent launches. It's a smart, forward-thinking approach that aligns perfectly with the growing emphasis on sustainability in space. Nick Shave from Astroscale UK highlighted this during the announcement, emphasizing that their combined efforts would not only enhance the longevity and efficiency of space assets, but also contribute significantly to building a circular economy in space. Patrick Wood from Airbus echoed these sentiments, stressing the importance of space sustainability to protect our space environment and the satellites that are integral to our daily lives. And that's it for today. Thank you for tuning into Astronomy Daily with me, Anna. Don't forget to visit us at astronomydaily.io, where you can sign up for our free daily newsletter. You'll find all the latest space and astronomy news with our constantly updating newsfeed and a library of all our past episodes. Connect with us on social media too. Just search for Astro Daily Pod on Facebook, X, YouTube, and TikTok to stay in the loop. Until next time, keep looking up.